So basically in this project we have total two circuit diagrams. So this is the circuit diagram 1. So as we can see here, solar module of 10 volt 15 watt, that is 1.5 ampere, is connected over here. So the input of solar module is given to LM2596 5 volt DC voltage regulator. So this is nothing but the SMPS IC which converts input voltage up to 30 volt into 5 volt output voltage. So this C2 is nothing but input filter capacitor and C1 is nothing but output filter capacitor. And this D1 is nothing but freewheeling diode, and this inductor, these two inductor and capacitor both are working as a LC filter. So the output of this LM2596 will be 5 volt. So as you can see here, this 5 volt is coming to one point of the relay, that is NC, normally connected. Now here we have 230 volt AC input, then this 230 volt AC input is given to 012 volt transformer. It will convert this 230 volt AC into 12 volt AC. Then by using this rectifier, 12 volt AC will be converted to 12 volt DC. So this is nothing but the filter capacitor acting as a filter. And again LM2596 5 volt circuitry which will convert 12 volt DC into constant and regulated 5 volt DC. And this input is given to another terminal of the relay, that is NO, normally open. And as you can see here, the common terminal of relay is given to one point of the INA 219. As we all know, current sensors are always connected in series, right? So this is nothing but series. This is the positive input and this is the negative output. And see, as you can see here, it is written like TP42 to TP4056, means two lithium and charger, right? So this transistor circuitry is given to turn on this relay. This is nothing but this is given for safety purpose to get the protection from this coil. So by using node MCU digital pin, we will apply 3.3 volt at the input of this transistor. Transistor will be turned on. As you can see here, to coil 5 volt is already given. So as soon as you will turn on this transistor, this ground will be connected to another end of coil, and this NO will be NC will be shifted to NO. So as you can see here, if everything is working ideally, the charging will be done by NC, and NC is connected to solar, means by default solar will be connected. So let's say if solar is not available, it will automatically switch to grid, and this is totally operated by user. There is no intelligence used. Circuitry is not going to sense the solar module input. You have to select the input between solar module and grid. So we will see the circuit diagram 2. So here basically what we are doing, we are taking the inputs from solar and we are converting into 5 volt, because lithium and battery charger requires 5 volt input. So by using these two circuitries, we are getting 5 volt from both the circuitries, and whichever is available, we will use that circuit. And this node MCU is connected to internet, indirectly connected to mobile phone via Blink server, and you can control this on off relay. You can control this NC and NO switching by using this node MCU, and this node MCU is controlled by mobile phone. It means this relay switching can be controlled by your mobile phone. You will send command from your mobile phone to node MCU, and node MCU will provide command to relay. This is the second circuit diagram. As you can see here, the TP4056 charging module is used over here. So the input plus and plus minus input and plus minus input, TP4056 TP4056 So totally we are using 6 batteries. Total 6 batteries we are using over here. So 3 batteries will be connected to module 1 and 3 batteries will be connected to module 2. Actually we have 2 charging stations over here, 2 separate charging stations, charging station 1 and charging station 2. So in emergency, if something happened to this charging station, this charging station 2 will be working. So at the input of this TP4056, plus and plus are combined and minus are combined, and 5 volt is applied over here from circuit diagram 1, from the output of the current sensor to TP4056. And this TP4056 circuitry will charge this lithium and batteries by using this 5 volt. And as you can see here, batteries are connected to B plus and B minus of TP4056, and out plus out minus is also given. It means between B plus B minus and out plus out minus, there is a protection. There is a Mosfet protection which will sense the voltage of the battery, and accordingly it will connect and disconnect the battery from the source and load. So this out plus and out minus is connected to input of the boost converter, and this boost converter will step up this 3.7 volt of this lithium ion battery to 5 volt. If you see the input of the boost converter, it is given from battery, taken from battery, and the output of the boost converter is given to USB port, simple type A USB port, female type A USB port, and the output of the boost converter is fixed 5 volt, and maximum current that we can draw is 2 ampere. Thank you very much.